Chapter 11, question 114. Now, they have barium carbonate and magnesium carbonate powders mixing together. Okay, then the mixture is heated with Bunsen burner flame until no further change. A gas is given off. So, you have two group 2 carbonates. One is magnesium carbonate, the other one is barium carbonate. So, magnesium carbonate, okay, is easier to be decomposed, okay, because it's less stable thermally compared to barium carbonate, because barium carbonate is below magnesium carbonate in group 2 carbonates, right? So this one less stable, that means easier lah to decompose. Barium carbonate, okay, more stable, need more energy, they only can decompose. So when you heat this mixture, okay, using Bunsen burner flame, actually only magnesium carbonate is decomposed. This one did not decompose. So the CO2 given off is actually CO2 from magnesium carbonate, right? That is why you see number one, the residue left after heating reacts with aqueous hydrochloric acid to produce carbon dioxide, because this barium carbonate is still in solid form, didn't decompose upon heating. So when you add acid that time, then the acid will react with this barium carbonate to give off more carbon dioxide. So statement 1 is correct. Now statement 2, the percentage decrease in mass after heating is 26%. Now we look at the question again. They mix barium carbonate and magnesium carbonate in equal masses, meaning if I mix 1 gram of barium carbonate, okay, I need to add 1 gram of magnesium carbonate also. That's why equal, the mass is equal. So they are asking, now if I mix 1 gram of barium carbonate and 1 gram of magnesium carbonate together, okay, what is the percentage decrease in mass after I heat? Because only magnesium carbonate decomposed, barium carbonate didn't decompose, right? So after heating, I will, okay, let me write the equation. So if I have MgCO3 plus BaCO3, so after the heating, sorry, it's Mg. After the heating, I get MgO plus CO2 plus BaCO3, because barium carbonate did not decompose. Okay, so this CO2 is a gas, so it will escape from the system. So what is left will be magnesium oxide and barium carbonate also. We lost CO2. So what's the percentage in mass that we lost? Now this 1 gram and 1 gram is what I assume, because they didn't tell us what are the masses that they mix together. They didn't tell us or equal lah, right? So what do I need to do is, I want to find the number of mole of magnesium carbonate. Okay, so I assume that we use 1 gram. So 1 divided by 24.3 plus carbon is 12 plus 16 times 3. Oops, sorry, cannot see. Okay. Okay, let's do some calculation. Okay, 0.0119 mole. Okay, then the number of mole of carbon dioxide will be the same as this, because 1 mole of magnesium carbonate will give you 1 mole of carbon dioxide. Okay, now let's find the mass of carbon dioxide. 0.0119. Okay, multiply by 12 plus 16 plus 16, 44. Okay, 0.524 gram. Okay, now, so initially, I have 1 gram of magnesium carbonate, 1 gram of barium carbonate. Okay, at the end, okay, I lost 0.524 gram of carbon dioxide. So, mass loss equals to 2 gram. Okay, sorry, mass loss is 0.524 gram because that is the mass of carbon dioxide. Now, let's find the percentage loss. Will be 0.524 gram divided by 2 gram. Okay, then this whole thing multiply by 100. Okay, they want us to round the answer to two significant figures, so it's 26%. So number 2 is also correct. Now let's look at number 3. The gas given off during heating relights a glowing splint. So what type of gas will relight a glowing splint? That must be oxygen. But if you look at the equation, any oxygen was given off? No. Okay, only carbon dioxide. So number 3 is incorrect. So only 1 and 2 are correct. Answer is B.